topics anytime soon. This is generally a point in time where we have people who are new to say hi, what they do with data engineering.
I don't know what happened, but I can't hear Arpin anymore. Can you guys hear him?
No, I can't either.
Okay, he might be having issues. Can you take over, Josh?
I can.
Thanks.
Grab the
Yeah, I think we lost Arpin.
intro slide. Sorry about the technical difficulties, guys. Bring up my webinar. Okay, are you guys able to see my screen?
Yep.
All right, I believe we were at anyone new to the data engineering lunch today. If you'd like to introduce yourself and share with us what you tend to do with data engineering, or what brought you here, what you hope to learn, that sort of thing. I won't force anyone, so we can move on. Group rules, if you have a question, please ask it. Be polite and courteous to others and share what you know. This is meant to be a discussion. Here at Anant, we deal with real-time data and analytics platforms frequently. So this is something we're very familiar with and always enjoy sharing with the community what we know. DataStax is a partner in these talks, and we've done some talks with them recently, as well as George Washington University and some of the other program sponsors and organizational sponsors as well. And at this point in time, if anyone has any announcements, jobs, meetups, hackathons that they would like to promote, you can use this as an opportunity to do so. I'll take that as a no. One announcement from Anant is we are hiring for full-time or part-time positions as data platform operators, engineers, and architects. If this is something you or someone you know would be interested in, please check out careers.anant.us and connect with us there. Some upcoming events. We have a sister event to this every Wednesday. And this Wednesday's Cassandra Lunch will be presented with a guest speaker, Peter Corliss, and he'll be talking about ScyllaDB. Definitely don't want to miss that, as well as deploying Cassandra using Kubernetes Cas operator. You can find all of our events listed at anant.us/events. And with that, we can pass it off to Obi. Sorry for the little hiccup there in the middle of that, but you know, let Obi take over.
Thanks, Josh.
All right, is my audio coming through?
Yep.
All right, cool. I'm Obi Anamnachi. I am a data engineer here at Anant. I apologize in advance for any coughing fits. I'm still getting over a bit of an illness. But our topic today is Apache Livy, which is an Apache project. It's a tool that creates a REST API for your interactions with your Spark clusters. You can submit jobs. It helps you manage your Spark context. And actually does some interesting things with your cache data that we'll talk about a little bit. During the course of this presentation, I generally prefer to take questions in the chat, and we'll answer them when we reach a good stopping point. But if you do have something interesting to add, feel free to speak up. So just starting out, what is Apache Livy? the tool that enables users to interact with the Spark cluster via REST interface. It also includes programmatic API interfaces for Python, Java, and Scala. So you can trigger these from inside your code as well. It allows users to submit jobs as precompiled jars. So you can submit your jar file and run like you would with Spark Submit, or you can submit snippets of code via the REST API, and it'll run them. This is actually something that sort of backed the way that PySpark would interact with notebooks, various notebooks in the past. And it also comes with a Java, Scala, Python client API. It helps you manage your Spark contexts, including allowing them to be used by multiple jobs or by multiple clients. And then jobs that are using the same Spark context also will share the same cached RDD data frames and data sets across those multiple jobs. You can submit your jobs without having a Spark client on your machine. And your existing Spark code doesn't actually need to be changed in order to be compatible with Livy. So you can see this is their sort of architecture. You have your Spark cluster over on the right. It has drivers with Spark contexts and executors that do the work. And then also on that cluster is the Livy REST server. And then your outside clients communicate with them according to those contexts over HTTP. And then the various job submission options that Livy sort of enables are the ones that you would use without Livy. Normally, if you wanted to interact with your Spark cluster, you would either do it through the Spark shell in Python, Scala, R, SQL, any of those options, or via submission of batch jobs using Spark Submit. These aren't super different. You can use deploy mode client to get the same sort of REPL shell that you would get in the normal Spark shell. And then both of those methods of interaction rely on you having access to the cluster in a limited number of ways. So if you are on a machine that is part of the cluster, you can use the Spark bins and such to run Spark Submit or run Spark Shell and just do it that way. You can add your local machine to the cluster effectively. What you're actually doing is putting the Spark runtime on your machine and then using the Spark Submit that's there in order to submit to the cluster. What you're doing there is basically temporarily adding your node to the cluster in order to connect, or you can use a cluster gateway machine. And basically all of those give you access to a machine that is part of the cluster, which means that users have access to implementation details and configuration details of the cluster that you might not necessarily want them to have. And it makes it difficult to deny or allow for certain types of access to users in different security groups if you have a limited number of nodes or gateways to control that access. And also makes it a bit difficult to integrate with your existing security or access control solutions. And Livy sort of purports to solve all of these. So by having the API layer, you can control the way that users interact and stop them from getting the actual details of your cluster because they're only interacting with whatever the REST objects are. I'm going to be moving on to the demo real quick. So if there are any questions, now is a good time. So for this demo, we're going to be using Gitpod. The only things that I have included in this repository already are the Apache Livy runtime, and then a Spark installation that's specifically Spark 2.4.8. And the reason this is important is because right now Apache Livy is only compatible with Spark instances built on Scala 2.10 and 2.11. And all of these Spark 3.0 versions are Scala 2.12. And also Spark 2.4.2 is also Scala 2.12, and that's incompatible with Livy. You can probably build your own mess around with your dependencies and build your own Spark 3.0 on Scala 2.10 if you feel like messing around with dependencies for a while. Okay, so what we're going to start with today is just getting our Spark cluster up. We're working in Gitpod, so it'll be a one node cluster. Gitpod is an online IDE. You can open your Git repositories in it and have an environment to both edit and then and run and test your software. So the first thing we're going to do is go into the Spark folder. Start our master node. When that comes up, we actually need to open that in our browser so that we can get the Spark master IP. There we go. So we start our worker. And then actually what we're going to do is we're going to export an environment variable, Spark home, which Apache Livy uses. Make sure it's pointing to the location of our Spark install. We're going to exit back out. And then to start our Livy server, just going to run Livy server start. All right, and as you can see, it brings up the service on port 8998, mostly in order to not conflict with anything that Spark will be using. And the first thing we're going to do is we're going to run through their example. So first we want to make sure we have requests installed, which it should be, but just in case. Yep, we're good. We can open up Python, and what we're going to do is just going to kind of copy and paste these in for now. But you can see what it's doing. Defines host name.
You zoom in.
That you actually.
You can just zoom in for a second. Yeah, that's
here.
Yeah.
Okay. So the first thing you're doing here is you're defining your session. In the first session, all we're doing is creating one with kind Spark, and then we're sending that to the sessions API. Where is the actual docs for this? Yeah, so when you post to the sessions API, you create a session. You can define all sorts of Spark configurations and other variables here. But essentially what it's doing is it's creating a single Spark context with this configuration. And anytime you send code snippets to this session, it'll run them with that. And so this is the mechanism for sharing your cache data frames or showing your cached data frames or data sets or RDDs in between jobs. Because if they're using the same session, the Spark context won't go down in between things that you're doing. So if we make sure to import, these docs are actually a little bit out of date. We can see that the actual data that we're getting back. Can we zoom in here? I'm not really seeing options. What you can see is that we're actually getting back, well, we get one with a warning because of the amount of memory we're using. But we have created our session and it's in state starting. It's a Spark setting. We didn't define a proxy user, et cetera, et cetera. We can then go on to use that. Well, first we can use the sessions API to get the details of our session. When we first ran that, it came up as starting. But if we were to run this, we should get back well, it's in here somewhere that it started. And we can also go and check the UI actually. So Apache Livy has a very simple UI for keeping track of your interactive sessions where you can send statements, which are code snippets. And then we'll get to it later on, but you can also keep track of your batch sessions, which is when essentially you're using Livy to do a Spark submit. It'll start a batch session here and you can keep track of that as well. So we now know that our session is up and running. So we can have it do the simplest code snippet, 1+1. And we can see it's in progress. And then it's probably already done. But we can then use the statement URL that we posted this to in order to check the result. So you can see the data that we got back is text and it says res0 int 2. And this is exactly what you would get back if you typed the same 1+1 into the Scala shell. So essentially what the statements API is doing is giving you an interface to run your code snippets on the Spark shell and giving you back your results. We can also use it to run slightly more complicated code. In this case, instead of the 1+1, what we're doing is one of the Spark examples. We're using the pi approximation Spark example effectively, and we have the code for that here. It iterates and estimates pi over time, and we can see that once we post the request, tell right now that it's waiting. And you can see this is all still on the same session. We haven't started another session to run this. So this is the way that you would use statements to pass your cached RDDs in between your different code snippets. If you have a bunch of different code snippets that will do different things, but one of them will cache a data frame to the session, you can then run another code snippet and it'll have access there. It's almost certainly done now. So we can just look at our result. You can see samples 1000, count 7, 8, 474, it approximated pi to 3.13896. And more samples gives you a more accurate estimation of pi, as that sort of goes. So that's it for their example. We can close the session here, session 0. And now, actually, we're going to exit out of here because we're moving on to something that they don't quite have documentation for. Well, they don't have a full example worked out for. Actually, we need to stop Livy first, which is working with jar files. So the main way that Apache Livy wants you to use jar files is to, well, you set up your proper Spark environment variables when you're setting up the request. But what they want you to do is essentially have your jar file in S3 or in HDFS somewhere that Livy can access. And for that reason, the default of using jars that are on the local machine where Livy's or where Spark is installed is actually disabled. But we can re-enable it really quickly. So what we're doing is going to Livy conf, and we're making this a valid configuration file. And then we are going to find the local directory whitelist. And we're going to add the Spark example jar. We're effectively going to do the same example with the Spark Pi example. Luckily, they've in the Spark pre-built, they've compiled all of the example Scala files into this example jar file. So we can use that, and we can run the Spark Pi example from the jar and get it as a batch session. So once we save this, we can, it's uncommented, right? Yes. Again, I really apologize for the coughing. But we can start Livy back up and go back into Python. And first we have to set up the connection the same way as before. We get all our imports. We set the host IP port, and then we're going to define the batches URL, which is just the endpoint. Batches after the host name, because we are into, rather than using the sessions API, we're into the batches API. And then there's also down here the statement definition. So what we're going to do is we're going to define the body of our statement. What you're actually defining here is a bunch of the same, same configurations that you would give to Spark submit. In this case, in a JSON body, so you can send it with your REST API. Like I said, in this case, we're using a local jar file that's already on the machine where Spark and Livy are running. But you can also define a link to online storage like S3 or HDFS, where Spark will then pull your jar from, and it'll be able to run even if you don't have access at all to the machine where Livy's running. So it does essentially overcome that issue, where if you wanted to run your jar on Spark, you had to either add your local machine to the cluster or put your jar on the cluster and run it that way. This way you don't really need access to the cluster. You just need to be able to talk to Livy. So what we're actually defining here is the file path, what main class we're starting. It's org.apache spark example sparkpy, because we're doing the same sparkpy method that's defined, except it's in the jar this time. And then we're giving it an argument. Gave it 100 here, but I believe we gave it like 10,000 before. So we can increase that some. And then the jars that we're passing in, the same file path to the jar. And then we post this to the correct endpoint. Oh, I forgot to define the headers. That is here.
And while you're doing that, I just want to state the obvious that even though you're doing this from Python, you could do this with JavaScript in Node.js or in the browser for that matter, right? Technically,
Yeah,
it's
you
just
could
an
do it from curl or Postman, all the above. Anything you can send your request through.
Have you connected Jupyter or any of the notebook solutions to Spark using Livy?
No.
I think there's a plugin for Jupyter Notebook. I think it's called like Spark Magic or something. But it's a bridge between Jupyter and Livy. It's basically just giving you a web-based interface to this stuff. That may be a follow-up topic.
And it would make sense because essentially you just use the statements API and send your code snippets in the notebook directly via the REST API and get your results back.
Yeah, exactly.
All right, so just to show off this time, there are no normal sessions. So what we get at the top of the screen is the batch sessions. Batch session 0 still running. We can go look at the logs. And then essentially the difference between normal sessions and batch sessions is that because you're using deploy mode deploy mode cluster, these ones close after the running is complete, whereas the original sessions would linger. And I believe you can actually set that with your Spark configuration. You could force these to run in client mode. So you would get the same ability to pass your cache data frames in between different runs, in between jobs. I may have set that value too high.
What did you set a very high value for the number of digits for pi?
Yeah, for the number of iterations. I think it's using Newton's-Raphson method, so it's approximating closer and closer, but not like filling out a list of digits, just the way the math works out.
Yeah, that might take a while.
Yeah,
but it's a use case to show like you can start a long running process and just let it run and then come back to it.
Set up that. Let's see.
Basically, it's like the closest thing you can get to rapid wrapping Spark in without you making your own microservice. It basically exposes Spark as a microservice, as a REST API.
Yeah. And of course, you can have multiple running at the same time. So I just started another one with a very low amount. And if we were to go look at the logs, we can see approximated to 3.14, etc. And then this one with much more is approximated out to more digits. The original was 3.142. This one's 3.1415. And if you added more, it would take longer, but give you a more accurate answer. All right, that is most of what I have to show off for today. But before we head out, actually, there was something that I wanted to bring up that I saw in articles and in Livvy's documentation where people are talking about it. Basically, the website says Apache Livy also simplifies the interaction between Spark and application servers, thus enabling the use of Spark for interactive web mobile applications. And I'll be honest, I was a little bit baffled, just the sort of paradigm that they're implying here, where you're using Spark as your database to sort of back your applications. It seems a little bit alien. So just like as a thought experiment or a topic for discussion, where might you use this? Where is it better to like install Livy on your Spark cluster and then use that Spark cluster to furnish your applications rather than using Spark to do your processing, loading the process data into some other database and using that to furnish your application?
It's a good thought experiment. I mean, at this point, it's kind of implying, could you use Spark as your single, layer, kind of like Presto, or there are other technologies like Denodo. But to answer your question, I would ask you, can you do Spark SQL with like just saying like a pure select statement without wrapping it in Scala or Python code? Could you do a Spark SQL call from Livy directly, or no?
I don't know if it can like pass on directly a SQL statement. Yeah, you could definitely use a PySpark or a Scala or Java like wrapper and then use their Spark.SQL statement or whatever. I don't know if it has direct support for SQL queries though.
Yeah, I'd be still hesitant, just because of the latency, potential latency of a Spark job. But looked like a lot of the simple operations you were doing was pretty fast, because it keeps the session open if you tell it to keep it open. I think that's the big difference.
Yeah, the thing that I was thinking of when I thought of this is sort of like you're doing something that's like constantly updating. And so if your data in Spark is what you want to look at any given moment, there's no point in uploading it to another database just to look at it somewhere else. Like if you're generating a report that changes all the time in real time, maybe you might want to go to Spark directly for that data. Yeah,
exactly. I just found a link. I'm going to send it. Maybe we can put it in the blog post. But there's another UI which is used in the Hadoop world called Huey. But this article talks about using Livy and Huey as like a simple, web-based, editor for. Because I don't think you can like edit. It's basically more of a view the data, whatever select query you do. But I think, yeah, it looks like you are able to send a query, but you have to start a session in the SQL session. Like I think when you start a session, you set the kind of the session as SQL, and then you can give it select statements.
Okay.
Yeah, that's awesome. Well, I mean, then in that case, even if it's not directly connected to like a web application or a mobile application, if you were to wrap it with a REST API, which had some sort of caching engine, just to be a little bit more snappy than Spark, I think it could be possible. But what I'd be afraid of is, if the Spark cluster isn't properly sized, if somebody runs a very big job that takes up a lot of resources. So you have to have some intermediary to say, hey, no more than, these values are not allowed. Like you can't use this much memory or this many executors, because the quote unquote governor in the middle would basically block that from happening, right? But yeah, it seems like a cool idea. Good stuff.
All right. Yeah, that's all I had for today. So if there are any questions to end this off with, you can put them in chat and I'll get to them, answer them as best I can. Actually, since the presentation's over, you can speak up, unmute yourself and ask directly if you have questions.
I don't think there are any questions. So yeah, thanks. Great presentation, Obi. Thanks for doing this. Maybe the next one, we do Livy with some GUI tools like Huey or Jupyter, because I think that's a little bit more approachable for many folks. A lot of people are already familiar with Jupyter, and to be able to just run Spark without having to, know Spark, that'd be kind of cool.
Yeah.
Great. Thanks, everybody. Have a wonderful week. And yeah, we have a talk coming up on Wednesday on Scylla. I think that's how you pronounce ScyllaDB, which is a Cassandra compliant database written in C++. So looking forward to that. And otherwise, see you next week. Data Engineers Lunch, same time, same place. Take care.